Have you ever pondered how it is possible to observe galaxies situated billions of light-years away from Earth? These vast cosmic structures reside at distances so immense that even light, the swiftest traveler in the universe, requires billions of years to reach us. Such inconceivable spans might seem to render observation utterly impossible, yet humanity has achieved this feat through the construction of enormous astronomical telescopes. These instruments serve not merely as extensions of our vision to peer farther into the void, but as conduits that relay tales from the universe's distant past directly to us. In doing so, they evoke a profound sense of awe before the boundless beauty and mystery of the cosmos. Picture yourself standing atop a lofty mountain peak under the cover of night, with a gentle breeze brushing past, and the sky overhead adorned with stars that sparkle like jewels scattered across an infinite darkness. Many of those stars lie tens, or even hundreds, of light-years from us. The unaided human eye cannot discern such remote distances with clarity, yet astonishingly, their light traverses this immense expanse to arrive at our gaze. This light carries images of those stars as they appeared long ago, preserving echoes of bygone eras. Every celestial body in the universe, be it a star, a galaxy, or a nebula, emits electromagnetic radiation. Among this radiation is the visible light that our eyes can perceive. This light propagates through space at a velocity of approximately 300,000 kilometers per second, a speed so rapid as to defy easy comprehension, though the universe's colossal scales still demand extensive durations for its journey. When we describe a celestial object as being hundreds of light-years distant from Earth, we imply that its light necessitates hundreds of years to arrive here. For instance, the stars twinkling in the nocturnal sky reveal their forms as they existed hundreds of years in the past, akin to ancient letters dispatched from history. In essence, what we witness through a telescope at this moment is the appearance of those bodies from hundreds, or perhaps thousands, of years earlier. This light, like a patient sentinel, bears the ancient chronicles of the universe, piercing the frigid obscurity to be captured by terrestrial telescopes. Contemplating this truth stirs an exhilarating thrill within the heart, as if the stars were narrating timeless fables, where time itself expands into eternity. Recent investigations, as detailed in studies from 2025, indicate that this odyssey of light grows even more intricate due to the universe's ongoing expansion. As the cosmos enlarges, the wavelength of light stretches in a phenomenon known as redshift, arriving at us elongated beyond its original form. This mirrors the acoustic effect where the siren of a receding ambulance diminishes in pitch. Furthermore, cutting-edge research published in Frontiers in Astronomy and Space Sciences in late 2025 explores cosmological redshift as potentially arising from nonlinear critical dynamics, suggesting that gravitational phenomena might stem from emergent critical behaviors in complex systems, adding layers of complexity to our understanding of how light's path is altered across cosmic voids. The human eye, despite its remarkable sophistication, possesses inherent limitations in capturing faint light from such profound distances. Consequently, astronomical telescopes have been engineered to surmount these barriers. At their core, these devices function as colossal collectors of light, amplifying and focusing the exceedingly feeble photons emanating from remote celestial entities. The clarity of a telescope's observations hinges directly upon its capacity to gather light, which scales with the square of its aperture diameter. For example, a telescope with a 2-meter aperture boasts a light-collecting area 4 times greater than one with a 1-meter aperture. A larger aperture permits the accumulation of more photons within the same time frame, much like a broader funnel gathers a greater volume of rainwater. Light from galaxies billions of light-years away arrives attenuated by both distance and the universe's expansion, yet large-scale telescopes seize this dim radiance and transform it into vivid imagery. Through this process, scientists gain deeper insights into the evolutionary narrative of the cosmos, tracing its progression from primordial chaos to the intricate architectures we behold today. Consider, as an illustration, the Keck telescopes perched upon Mauna Kea in Hawaii. These comprise 2 primary mirrors, each measuring 10 meters in diameter. The light-collecting surface of each mirror approximates the expanse of a tennis court, rendering it over 600,000 times more efficient at amassing light than the human eye. This prowess enables the Keck telescopes to detect illumination from galaxies exceeding 13 billion light-years distant, primitive formations that coalesced roughly 400 million years subsequent to the Big Bang. Observations from the Keck telescopes, alongside others, have illuminated entities such as GNZ11, a galaxy that unveils the universe's nascent phases, where the inaugural stars ignite amid the gloom. Scientists leverage these glimpses to comprehend how the cosmos transitioned from a searing turmoil to its present-day complexity. Discussions in prominent scientific forums posit that such galaxies might harbor fundamental building blocks for life. In recent developments from 2025, the Keck Observatory has unveiled groundbreaking findings, including the first spatially resolved, gravitationally lensed superluminous supernova, designated SN 2025WNY, which offers unprecedented views of explosive stellar events magnified by cosmic lenses. Additionally, collaborative efforts with the Subaru telescope have revealed a massive planet and a brown dwarf encircling distant stars, providing fresh perspectives on planetary formation processes and the dynamics of accelerating stellar systems. These discoveries underscore the Keck's enduring role in peeling back layers of the universe's hidden realms. Presently, humanity's most advanced space-based telescope is the James Webb Space Telescope. Its primary mirror spans 6.5 meters, yielding a light-collecting area surpassing 25 square meters, equivalent to millions of human eyes scrutinizing the heavens in unison. This capability allows it to ensnare ancient light imperceptible to ordinary vision. The James Webb Space Telescope operates predominantly in the infrared spectrum. For distant objects undergo redshift, shifting their ultraviolet and visible emissions into infrared wavelengths due to the universe's expansion. This redshift phenomenon, akin to the lowering tone of a departing ambulance siren, elongates light's wavelength as space itself stretches. The telescope's sophisticated infrared detectors peer beyond the veil of visible light to scrutinize extraordinarily archaic galaxies. Among its 2025 revelations is the galaxy JADE's RGS Z14-0, existing a mere 290 million years post-Big Bang, shattering prior records. Scientists from the National Aeronautics and Space Administration and the European Space Agency infer that this galaxy may contain unexpectedly intricate molecules, such as oxygen and organic compounds, hinting that life's precursors could have emerged earlier than previously conceived. Further afield, the James Webb Space Telescope has captured Neptune's luminous auroral displays for the first time, observed an exoplanet with a peculiar lemon-like shape and enigmatic atmosphere that defies conventional models, and provided the strongest evidence yet for an atmosphere enveloping a rocky exoplanet, described vividly as resembling a wet lava sphere. It has also documented a new moon orbiting Uranus, probed filamentary structures that may illuminate dark matter in novel ways, and identified over 300 unusual early galaxy candidates that challenge existing theories of cosmic formation. In August 2025, it observed an interstellar comet and a cosmic entity dubbed Virgil, a shape-shifting supermassive black hole precursor that prompts re-evaluation of black hole growth in the nascent universe. Telescopes afford not only the ability to see but to discern with enhanced precision. Their capacity for detailed resolution depends upon the aperture. According to the principles of wave optics, the theoretical angular resolution is proportional to the wavelength and inversely proportional to the aperture diameter. Thus, a larger aperture yields superior resolution, enabling the distinction of finer particulars. For instance, the Hubble Space Telescope, with its 2.4-meter diameter, achieves an angular resolution of 0.05 arcseconds. This permits the differentiation of individual stars within the Andromeda Galaxy, 2.5 million light-years away, and the analysis of their ages and temperatures. Hubble's imagery captivates scientists, portraying the universe not as a cold emptiness but as a realm brimming with color and motion, capturing the birth of new stars amid colossal gas clouds. The European Southern Observatory's extremely large telescope, currently under construction with a primary mirror diameter of 39 meters, is slated for full operation by approximately 2030. Its resolution will approach 0.005 arcseconds, facilitating direct observations of surface features on Earth-like planets beyond our solar system, alongside assessments of atmospheric presence, surface temperatures, and potential liquid water. Scientists at the European Southern Observatory speculate that the extremely large telescope could detect biosignatures, such as oxygen or methane, on distant worlds, inaugurating a new era in the quest for extraterrestrial life. Imagery from the extremely large telescope's construction site in the Chilean Andes, captured in December 2025, depicts the emergence of the world's largest optical telescope amid the rugged peaks, with its secondary mirror, measuring 4.25 meters, the largest of its kind, completed earlier that year. Nevertheless, visible light constitutes merely a fraction of the electromagnetic spectrum. Numerous distant objects, particularly primordial galaxies, exhibit light that has been redshifted into longer wavelengths by the universe's expansion. Hence, contemporary telescopes like the James Webb prioritize infrared observations. In August 2025, the James Webb revisited the Hubble Ultra Deep Field, a minuscule patch of sky comprising but 1/13 of the celestial sphere. Through nearly 100 hours of exposure, it unveiled over 2,500 remote galaxies, some forming between 400 and 500 million years after the Big Bang. By fixating a telescope upon the same region for hours, days, or even weeks, arriving photons accumulate gradually to forge crystalline images, reminiscent of discerning a grand symphony from scattered musical notes. Advanced technology propels telescopes into space to evade Earth's light pollution and atmospheric distortions, as exemplified by Hubble, James Webb, and Euclid. These yield pristine vistas that infuse humanity with humility and hope. The expansion of the universe induces redshift, a discovery attributed to Edwin Hubble, wherein space's stretching elongates light's wavelength in tandem. Recent 2025 research, including simulations of redshift drift in relativistic n-body models, posits that this drift could directly measure cosmic expansion's evolution, while investigations into high redshift phenomena, such as galaxies, quasars, and the 21-centimeter line, foster unified insights among theorists and observers. Telescopes do not merely observe objects billions of light-years distant, they collect and decipher ancient photons that have voyaged for billions of years. By enlarging lenses, heightening sensitivity, broadening wavelength coverage, and refining image processing techniques, we extend the frontiers of the observable universe. Each gaze through a telescope constitutes a dialogue with the cosmos's antiquity. The light from far-flung galaxies not only illuminates the night sky but guides humanity's exploratory odyssey, posing queries about our origins and destiny. Perhaps the answers reside in the next faint glimmer that a telescope captures from the deep. Yet, beyond the lens of telescopes, humanity draws nearer to the cosmos through the direct encounters of astronauts, engendering profound shifts in perception. Dozens of spacefarers have endured psychological crises upon viewing Earth from orbit, compelling agencies like the National Aeronautics and Space Administration to handle such revelations with caution. The root lies in the terrifying realization that humanity perpetrates errors on a cosmic scale. Nearly every astronaut, upon return, echoes the same sentiment: we must reconsider our modes of living and our treatment of one another. More alarmingly, this effect proves contagious. Individuals reportedly begin to feel unease after staring at photographs of Earth from the Moon for merely 30 seconds. In 1969, during the Apollo 11 mission, Buzz Aldrin fell silent for 17 minutes upon beholding Earth, prompting ground control to suspect a malfunction and issue repeated calls. When he responded, his words stunned: "We do not truly belong to Earth, we are trapped here." The National Aeronautics and Space Administration promptly severed the live broadcast. Later, Aldrin described Earth from the lunar vantage as a fragile blue glass marble, exquisite in its delicacy, imparting the insight that planetary conflicts hold no meaning. Alexei Leonov's reaction proved even more vehement. On the 18th of March 1965, aboard Voskhod 2, as he opened the hatch, his hands trembled uncontrollably, not from cold, but from terror. The vista shattered his worldview, Earth suspended in absolute blackness, not mere darkness but a void capable of devouring the soul. More shocking was the invisibility of national borders from this perspective. At that moment, millions of soldiers stood arrayed along frontiers, prepared to perish for national honor. Yet Leonov perceived that the boundaries they defended with their lives were imperceptible from space. In that instant, he grasped that humanity perishes for illusions. Leonov later recounted how this experience bestowed deep peace while compelling contemplation of war's futility. Scientists term this the overview effect, a cognitive transformation wherein Earth is perceived as a unified whole. A 2025 study from the National Aeronautics and Space Administration, reflecting on 25 years of low Earth orbit experiences, highlights how this arises through views from modules like the cupola, framing Earth against the universal backdrop and fostering interconnectedness. What they fear most is the effect's proliferation. No longer must one venture to space, mere photographs suffice to induce it. After 50 years of inquiry, psychologists have uncovered a fatal vulnerability in the human brain, regions that construct notions of self and boundaries, defining identity and affiliation. Viewing Earth adrift in the void halts these areas, akin to a computer rebooting after a power outage, your entire worldview erased and reinstalled. This alteration is irreversible. Neuroscientists confirm permanent changes in the prefrontal cortex of spacewalking astronauts via brain scans. The shift strikes instantaneously, like a heavy hammer upon the soul. Research from 2025 in Psychology Today suggests that meditation can emulate this overview effect, replicating the intense awe of gazing upon Earth from space and permanently reshaping life's perceptions. More terrifying still is the accompanying cosmic solitude. In 1969, Buzz Aldrin became the second human to tread the moon. While the world celebrated, the journey ravaged his later life. He succumbed to alcohol addiction, endured multiple divorces, and attempted suicide. Decades on, he confessed the truth. Gazing upon Earth from the lunar surface rendered return to his former self impossible. He had been a man who believed everything mattered. He likened that moment to beholding a blue glass marble, perilously breakable, upon which humanity's glories, wars, loves, and hatreds unfold. The universe remains indifferent. Post-return, existence grows arduous. At the dinner table, as family squabbles over dishwashing duties, you, who have returned from the moon and seen Earth floating in nothingness, perceive their bickering as trivial. When a superior discusses promotions and salary increments, you recognize those figures as meaningless. As nations wage war over territories, you know the borders they bleed for do not exist. It feels like having glimpsed the game's conclusion only to recommence from the start. Laboratories have interviewed hundreds of astronauts, yielding shocking outcomes. Over 90% felt alien-like in the initial months post-return, unable to fathom why people clashed over trifles. The most harrowing side effect is isolation, for you have witnessed a truth unseen by 99.99% of humanity. You realize the impossibility of conveying this secret. Declare borders fictitious, and others deem you naive. Proclaim Earth's aching fragility, and they accuse you of spreading dread. You become an outsider, privy to truth yet unable to revert. This solitude surpasses physical isolation by 1,000-fold. It resides at the soul's level. A 2025 study in Frontiers in Virtual Reality terms the ultraview effect as emerging when human spirituality extends to the cosmos, while the overview effect instills a sense of connection and the imperative to safeguard all upon this blue orb. In 2003, China's inaugural astronaut, Yang Liwei, described a akin sensation. Peering downward revealed an abyssal blackness, like an infinite chasm. Despite secure tethers, he could not release his grip. That darkness evoked the sensation of imminent engulfment, not cowardice, but an instinctual response to boundless nothingness. Yang reported hearing peculiar knocking sounds within his spacecraft, prompting reflections on human isolation in space. Scientists later attributed these to thermal fluctuations. On the 7th of February 1984, Bruce McCandless undertook an even bolder act, the first untethered spacewalk, propelled solely by a 110-kilogram jet backpack. A malfunction would have consigned him to orbit as a living satellite until oxygen depletion. Mission control technicians held their breath. Later, McCandless revealed that during those 90 minutes, the greatest terror stemmed not from mortal peril but existential solitude. Behind lay infinite void, beneath a distant Earth, and betwixt naught. Suddenly, all that mattered, home, vehicle, vocation, adversaries, resided upon that diminutive luminous speck. The universe cares not. Upon re-entering the shuttle, his initial words silenced all. Now we truly comprehend that we are nothing. This represents no feigned humility but an awakening of awareness. Confronting infinite cosmos activates a deeply concealed cerebral switch. Once triggered, reversal proves impossible. One might deem this tales of yesteryear, but nay. In 2021, at 90 years of age, William Shatner ascended via Blue Origin's rocket. The actor, who portrayed a starship captain for 5 decades, collapsed post his 4-minute cosmic sojourn, not from exhilaration, but irrepressible sorrow, weeping uncontrollably. Shatner depicted Earth as a fragile blue jewel amid chill darkness, awakening recognition of planetary strife's absurdity and spurring calls for environmental stewardship. This affirms the overview effect as no psychological suggestion but a replicable, verifiable phenomenon. Astronauts like Ron Garan recount perceiving all as interconnected from space, with borders as human-fabricated illusions. Psychologists at the University of Pennsylvania investigate the profound or induced by viewing Earth from space, a self-transcendent quality of wonder, elicited by striking visual stimuli. On the 14th of February 1990, Voyager 1 captured the iconic pale blue dot image from 6.4 billion kilometers. Therein, Earth appears as a faint speck of 0.12 pixels, adrift in vast obscurity. Astronomer Carl Sagan, upon viewing it, penned, "Every person you love, every individual you know, every soul of whom you have heard, has lived out their existence upon that minuscule point. Our every triumph and tribulation, thousands of religions and ideologies, every hero and coward, all exist upon that mote of dust suspended in a sunbeam." These words pierce the overview effect's essence. Realizing humanity's cosmic placement evokes dual contradictory emotions, sanctity in our shared fate and the senselessness of discord, juxtaposed with overwhelming emptiness and solitude. Given Earth's fragility and our diminutiveness, we must cherish this azure world and one another. Through art and technology, the overview effect extends beyond astronauts alone. The next occasion anxiety, anger, or petty quarrels ensnare you, envision that scene, from 6.4 billion kilometers in the gloom, Earth manifests as a dim luminous point, encompassing all you hold dear. This contemplation may not eradicate woes, yet it reframes them. What truly matters? Herein lies the overview effect's ultimate boon, not despair, but enlightenment. Linked to telescopic observations, the universe emerges not as a remote domain but a mirror reflecting ourselves, urging better stewardship.